a physical science lesson video for section 20.1, and as always, if you want my videos all in one place, just subscribe to my channel. So chapter 20, we're talking about electricity. So electric charge is a property that causes subatomic particles such as protons and electrons to attract or repel each other. The SI unit of electric charge is the Coulomb, which is represented by a capital C, and protons have a positive charge and electrons have a negative charge. Okay, so electric charge you can attract or repel depending on what the charges that the particles have are. So a cloud of negatively charged electrons surrounds the positively charged nucleus in an atom. So we have a positive nucleus in the middle and we have our negative electrons around the outside. The atom is neutral because it has an equal number of positive and negative charges. Now when you learn more about atoms, you will find that they can lose and gain electrons, but then they're no longer referred to as atoms, they're referred to as ions. Okay, so if something is an atom, a true atom, it will be neutral. And so if it has 6 protons, it has 6 electrons. If it has 40 protons, it has 40 electrons. If an atom gains extra electrons, remember electrons are negative, it becomes a negatively charged ion. And if an atom loses electrons, remember electrons are negative, then that means it becomes a positively charged ion. So positive charged ions have nothing to do with gaining protons. It's either gaining or losing electrons, which makes an atom have a charge. So here's an example of we have a sodium atom. It loses 1 electron, which is a negative charge, so now it's sodium with a positive 1 charge. And here's an example of sulfur. It gains 2 electrons or 2 negatives, so now it has a negative 2 charge. And a lot of you get this backwards because you want to think of the positive 1 as a plus 1. So you want to think, oh, well, plus 1, it gained 1 electron. Okay, no, it's saying that you have lost a negative, so now you're left with a positive 1 charge. Like charges repel and opposite charges attract. So 2 positives will repel, 2 negatives will repel, a positive and a negative will attract. The same thing works with the poles of a magnet. The force of attraction or repulsion between electrically charged objects is electric force. The electric force between 2 objects is directly proportional to the net charge on each object and inversely proportional to the square of the distance between them. So in other words, the higher the charge, the more they'll attract or repel. But it's inversely proportional to the distance. So in other words, the further apart they are, the less attraction or repulsion they'll experience. The closer they are together, the more it would experience. And so again, here's an example. We have 2 positives, so they don't like each other, so they're repelling. But here we have 2 positives, but notice they're further apart. So they're still repelling, but they're not repelling quite as much. And here's an example of the charged one. Here we have 2 positives, they repel. Here we have 2 double positives. So notice the line is bigger. They're repelling even more from each other. And that's just based on Coulomb's law. The effect an electric charge has on other charges in the space around it is the charge's electric field. The strength of the electric field depends on the amount of charge that produces the field and on the distance from the charges. So that's the same thing we said about Coulomb's law. How large is the charge and how close are they together? The more net charge an object has, the greater the force on it. The direction of each field line shows the direction of the force on a positive charge. Okay, so here's an example of a field line. So this is a positive particle, so the reason the field lines are pointing away is it's the direction that another positive charge would have. Well, would 2 positives attract? No, the other positive would go in the opposite direction. Whereas when you have a negative particle, field lines point towards the negative particle because again, field lines are based on a positive charge. So if a positive charge came around, it would be attracted to the negative, so it would come towards the negative. Static electricity is the study of the behavior of electric charges, including how charge is transferred between objects. The law of conservation of charge, just like law of conservation of anything, states that the total charge in an isolated system is constant. Charge can be transferred by friction, contact, or induction. So let's talk about those. So, charging by friction. Rubbing a balloon on your hair is an example of charging by friction. Electrons move from your hair to the balloon because atoms in rubber have a greater attraction for electrons than atoms in your hair. And so once you get those opposite charges, your hair is attracted to the balloon. Okay, and so if you rub it, then that's where the charging by friction comes from. Charging by contact. When a girl touches the Van de Graaff generator sphere, she acquires a charge large enough to make her hair stand on end. So she's not rubbing the sphere, she's just touching the sphere. So this would be an example of charging by contact. And then charging by induction. When you pick up extra electrons when you walk across the carpet, your hand is now negatively charged. The net negative charge in your hand repels the electrons in the metal doorknob. Overall, the doorknob is still neutral, but the charge has moved within it. So, a transfer of charge without contact is called induction. So, this is an example. They're bringing a negatively charged rod towards the metal ball. Let me let the picture start over, okay, which is just neutral right now. So once that negative charge comes, the electrons want to run away from the negative charge. So they come down here, and that causes these two leaves to separate. Because if both leaves are negatively charged, they're going to repel one another. Okay, so as that negative charge flows down here, those leaves repel and separate from one another. Now, did the negatively charged rod actually touch the metal ball? No, so that's why it's by induction instead of contact. And it wasn't rubbed, so it wasn't friction either. So, static discharge. The spark you feel when touching a doorknob is static discharge. Static discharge occurs when a pathway through which charges can move forms suddenly. Lightning is another example of a static discharge that occurs because charge can build up in a storm cloud from friction between the moving air masses. So once a pathway is formed where the charge can be released, it's kind of like, think of it as like an excess buildup of charge, and it just wants to release. Once a pathway forms, it can release through static discharge.
Would the following students please come to the front office? Aaliyah Haynes, Bryson Hill, and Avante Johnson. Alyssa James, Aaron Daniels, and Patrick Bailey. Will the following students again please come to the front office? Aaliyah Haynes, Bryson Hill, Avante Johnson, Alyssa James, Aaron Daniels, and Patrick Bailey.
Well, that was a lot of names. Alright, so section assessment. How is a net electric charge produced? Well, a net electric charge is produced as long as your charges don't cancel. Okay, so if you have the same amount of positives and negatives, it will cancel and be neutral. So as long as your charges don't cancel, that's when you have a net electric charge, when your charges don't cancel. Oh my gosh.
Keandra Harris, please come to counseling. Keandra Harris, please come to counseling.
Well, let's hurry so I don't keep getting interrupted. All right, what determines whether charges attract or repel? Well, whoops, sorry, I pointed at attract. Like charges will repel, and this should say or. Goodness, my typos. Attract or repel. Like charges repel, opposite charges attract. Okay, so like charges repel, opposite charges attract. Name two factors that affect the strength of an electric field. Remember, it's the amount of charge and the distance between the particles. Oh my gosh, wow.
Following students please report to the counseling office. Kashika Patel, Kushi Patel, Sydney Moore.
Okay, so it's the amount of charge and the distance between the particles. List three methods of charge transfer: friction, contact, and induction. Friction, contact, and induction. Explain how a static discharge occurs. Well, there's a buildup of charge, like an excess of charge, and then once a pathway forms where it can be released, that's when the static discharge occurs. So there's a buildup of excess charge, and once a pathway forms, so like if I have a buildup of charge and I'm going to touch this metal and a pathway forms where I can be shocked, that's what we feel when a static discharge occurs, it will release the excess charge that way. Alright, so how does electric force depend on the amount of charge and the distance between the charges? Well, remember, as amount of charge increases, electric force increases. So they do the same thing. They're directly proportional. My goodness. But as distance increases, the electric force decreases. So electric force and distance are inversely proportional. What is the law of conservation of charge? Well, like all laws of conservation, it says charge cannot be created nor destroyed, or of course the better way is to say that the overall charge in an isolated system remains constant. Okay, so the overall charge in an isolated system remains constant. And And last one, when a glass rod is rubbed with neutral silk, the glass becomes positively charged. Ooh, this should be a D. Boy, got a lot of typos going on. What charge does the silk now have? Well, if they're both neutral to begin with, and then one becomes positively charged, that means the other one has to be negatively charged because they have to balance out. So the silk would now have a negative charge. All right, so hopefully you know a little bit more about electricity, and we'll do some calculations on another lesson video.